So today we have an interesting geometrical problem. We take two congruent squares as you can see in this diagram. Now we draw a blue circle such that it is tangent to all the four sides of the square present on the right hand side. Now from this particular corner we draw a line segment such that it is tangent to the blue circle. Now we draw a yellow circle such that it is tangent to this white line and also it is tangent to the adjacent side of the square. Similarly, we draw a pink circle such that it is tangent to this white line and also it is tangent to the adjacent side of the square. Now the question over here is to find the value of the fraction area of the blue circle upon area of the pink circle plus area of the yellow circle. So this is Anmol and now let us see the solution. How can we solve this problem? So the first thing that I will do is I will simply mark the radius of this blue circle as a variable x. Now I can see that this particular blue circle is tangent at 5 points. First point, the second, the third, the fourth, and this is the fifth point. So what I will do is I will simply draw a radius to all that points. Now according to the theorem, the angle formed at the intersection of the radius and the tangent point is 90 degree. So the angle at all these 5 points become 90 degree. Now I can even mark the angle B and the angle C as 90 degree because they are the corner of the bigger square. Now look in this particular quadrilateral, all the three angles are 90 degree. Therefore by angle sum property the fourth angle is 90 degree. Similarly in this particular quadrilateral by angle sum property this is 90. Now I can see that this length, all these lengths are equal and it is equal to the radius of this blue circle. So in this particular quadrilateral all the four angles are 90 degree and the adjacent sides are equal and that are ultimately the radius that are having length x. Hence this quadrilateral is a square with side length equals to x. Similarly over here this quadrilateral, all the four angles are 90 degree, adjacent side are equal and they are equal to x. Therefore it is also a square of side length x. Now I can see that the distance from here to here is x, the distance from here to here is equals to x. Therefore the complete distance of BC would be equals to 2 times x. And this is happening when we take the radius of the blue circle equals to x. Okay, now these things are no more needed. They were just there to help us to find the side length of the square in terms of the radius of the blue circle. Now you may see I have kept these two radius that are perpendicular to the tangent points. Now what I will do is I will simply draw a line segment from this point D to this particular center of the blue circle. Now I can see that this right angle triangle and this right angle triangle are congruent to each other because of right angle, common hypotenuse, these two sides equal because they are the radius of the blue circle. So once two triangles are congruent, rest of the things between them become equal. This means this angle and this angle become equal and I will take them as a variable alpha. Okay. Now let this point over there be equals to point P. Now I can see that the angle PDC, that is this particular angle, is equals to 2 times alpha. Keep this as the equation number 1. Okay. Now I'll change the color for the second one. Now we have this yellow circle that is tangent at these 3 points. So if I draw a radius to these 2 points for now, the angle over there would be 90 degree according to the theorem. Now I will again draw a line segment from the point D to the center of this yellow circle. Now again these two right angle triangles are congruent to each other because of right angle, common hypotenuse, and these two sides are equal because they are the radius of the yellow circle. So once two triangles are congruent, rest of the things between them become equal. Therefore this angle and this angle become equal and let it be equals to beta. So this time I can see that the angle PDC is equals to 2 times beta and let this be equation number 2. Now by comparing equation 1 and equation 2, we can easily say that alpha is equals to beta. Now how can we utilize the fact that angle alpha and beta are equals to each other? So suppose I take DC as the base. Now what I can observe over here is that the slope of the white line is equals to alpha and the slope of this orange line is equals to beta. Now as we have got alpha is equals to beta, this means both of these lines are ultimately upon each other. This means the point D, the center of the yellow circle, and the center of the blue circle are in a straight line. So I can just erase all these things and draw a proper straight line. Okay. Now I will take the radius of this yellow circle as a variable y. Now what I can observe is that here we have a quadrilateral. 2 of its angle is 90 degree. This is 90 because it is the corner of this particular square. Hence by angle sum property this fourth angle is also 90 degree. Now these two adjacent sides are equal to each other because it is the radius of this yellow circle. Therefore, this particular quadrilateral is a square because all the four angles are 90 degree and adjacent sides are equal. So I'll just remove all these things from here. So as we saw, this quadrilateral is a square and the side length of this square is ultimately the radius of the yellow circle. Therefore, the distance from here to here would be equals to y, that is ultimately the radius of the yellow circle. Now the distance from the point D to this particular point, let the point be equals to point Q. So the distance from D to Q is the side length of this particular square, and we have already got the side length of the square as 2 times x. So this distance would also be equals to 2 times x. Recall that these two squares were congruent to each other. Okay. Now we can say that the complete distance from D to Q is 2 times x. This much distance is equals to y. Therefore, the remaining distance from here to here would be equals to 2 times x minus y. Okay. Keep this thing as it is, and these lengths are also equals to y. Remember that. Now take this blue circle. These lengths were radius and they were having a value x. Now take this particular right angle triangle. So I'll just draw that triangle outside the diagram. So the triangle is like this, this and this. Here's the point D, center of the blue circle, and here's the 90 degree. Now the height of this triangle is equals to x. So this much distance equals to x. This particular angle over here is equals to alpha. Okay. Now recall that in the blue circles we have drawn radius to these tangent points, and we have got that this quadrilaterals are square of side length equals to x. Now this much distance was the side length of this bottom square, and hence it would have a value x. Okay. The complete length of this side is equals to 2 times x. Some distance is equals to x. Therefore, the remaining distance, that is from the point Q to this 90 degree point, would have a value 2 times x minus x, that is x. Okay. Now what about the complete distance from the point D to this perpendicular? So in between we have the point Q. From Q to the perpendicular, the distance is equals to x, and the distance from the point D to Q is the side length of the left hand side square, hence it would have a value 2 times x. Therefore, the complete distance from the point D to that perpendicular is going to have a value 3 times x. Okay. Now here we have a right angle triangle. The height is x, the base is 3 times x. Therefore, the value of the tangent of alpha would be equals to 1 upon 3. Okay. Now this thing can be utilized very nicely. Take this right angle triangle that has been formed using the radius of the yellow circle. Here's the point D, the center of the yellow circle, and the 90 degree. This distance is equals to y. The length of the base we have already obtained, and that was 2 times x minus y. And here is the angle alpha. Okay. Now using this right angle triangle, we can get the value of tangent of alpha, and that would be equals to y upon 2 times x minus y. Okay. So we have already got the value of tangent of alpha, that is 1 upon 3. And now we have got the value of tangent of alpha as this particular thing. Therefore, we can clearly say that y upon 2 times x minus y would be equals to 1 upon 3. Let us solve this thing further. The value of y is equals to x upon 2. So here we have got the radius of the yellow circle in terms of the radius of the blue circle. Therefore, here we complete half part of the solution. So it is an important equation, so important. Okay. Now we will try to find the radius of this pink circle in terms of the radius of the blue circle. So for this pink circle also we have the similar situation. It is tangent at 3 points. So I'll draw the radius to that 3 points. The angle formed over there would be simply 90 degree. Now this angle is 90 because it is the corner of this square. These 3 sides are equal, and let the radius of this pink circle be equals to z. Okay. Now this quadrilateral over here will be a square. All the 4 angles 90. Adjacent sides are equal. Therefore, the distance from here to here would be z. The complete distance from A to D is 2 times x. Therefore, the remaining distance from here to here would have a value longer minus the shorter, and that would be 2 times x minus z. Okay. Now I will simply draw a line segment from the point D to the center of this pink circle. Okay. Now what I can see is that these two right angle triangles are congruent to each other. Right angle, common hypotenuse. These two sides are equal because they are the radius of the pink circle. So once two triangles are congruent, rest of the things between them become equal. Therefore, these two angles become equal, and let it be equals to a variable theta. Now I can say that the value of angle D is 90 degree because it is the corner of the left hand side square. Now as per the drawings that we have just done, 90 degree is equals to theta plus alpha plus alpha. and after solving this equation we will get theta plus alpha equals to 45 degree. So here we have got a nice relation between theta and alpha, that is addition of this both is equals to 45 degree. Now what I will do is I will simply take tangent on both of the side in this equation. Therefore, tangent of theta plus alpha would be equals to tangent of 45 degree. Now we know the identity of tangent of theta plus alpha, that is tangent of theta plus tangent of alpha divided by 1 minus tangent of theta tangent of alpha, and this thing is tangent of 45 degree, that is having a value 1. Now let me ask you a question. Can we replace tangent of theta and tangent of alpha with some other value? So the answer is yes. Recall that we have previously got the value of tangent of alpha and that was equals to 1 upon 3. Now what about the value of tangent of theta? So here we have this right angle triangle, and in this we have the angle theta, length of the height is z, and the length of the base is 2 times x minus z. Hence from this right angle triangle the value of tangent of theta would be equals to z upon 2 times x minus z. So these two values I will replace in this equation. So the equation will turn out to be z upon 2 times x minus z plus 1 upon 3 upon 1 minus z upon 3 times 2 times x minus z, and this thing is equals to 1. After some simplification work, this thing will turn out to be 3 times z plus 2 times x minus z equals to 6 times x minus 3 times z minus z. Now let us simplify the like terms. So on the left hand side 3 times z minus z plus 3z plus z equals to 6 times x minus 2 times x. Okay. Now the final result of the left hand side will be 6 times z, and this thing is equals to 4 times x. Okay, now to simplify this thing further, we can simply divide 6 on both of the side. So on the left hand side we will have z, and on the right hand side we will have 2 upon 3 times x. And here we have got the value of z in terms of x, that is ultimately the radius of the pink circle in terms of the radius of the blue circle. And this is the second important equation. Recall that we have already got the first important equation over here. Okay, so as we have got both of the important equation, let us proceed to the final step. So the question was to find the value of the fraction area of the blue circle divided by area of the pink circle plus area of the yellow circle. Now here in this question we took the radius of the blue circle as x, radius of the pink circle as z, and radius of the yellow circle as y. Okay, recall that the area of a circle is pi times the radius square. Now the radius of the blue circle is equals to x, therefore the area over there becomes pi x square divided by, now as the radius of the pink circle is z, area of the pink circle would be pi z square. But remember the second important equation in which we have the value of z in terms of x. So we'll simply replace that value over here. So the area of the pink circle that was pi z square will now turn out to be pi times 2 upon 3 times x the complete square, and this thing is ultimately 4 times x square divided by 9. Added with the area of the yellow circle, radius is equals to y, therefore area becomes pi y square. Now from the first important equation we have the value of y in terms of x, that is y equals to x upon 2. Therefore the area over here becomes pi x square upon 4. Okay. Now I can easily factor out the pi x square from the numerator and the denominator. So the final thing remaining will be 1 upon 4 upon 9 plus 1 upon 4. Now after taking the LCM and doing some basic simplification, this thing will turn out to be 36 upon 25. And this is the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment you can email me, or else you can send it to me on my Instagram. The link is in the description.